Hi folks, this is Calc 3, Checkpoint Quiz 20. We're asked to find a line integral, which is a work integral. It's written in differential form, and the path we're given is a two-part path. The first part is a line segment connecting 0 to 0, 1, and the second part is a parabolic arc connecting these 2 points. So we're going to use properties of the work integral. We know that the integral over c of f dot dr is the integral over c1 plus c2 f dot dr. And we can break that up. The integral over c1 f dot dr plus the integral over c2 f dot dr. That's a property of line integrals in general, and specifically work integrals. So let's look at these two paths. We've got a line segment followed by a parabolic curve. So here's C1 and here's C2. We're going to evaluate each of these independently. So let's look at the integral over C1. So I think the fastest way to handle this work integral is to parameterize it. And we've done lots of these in class and in your homework. We're going from 0 to 0, 1, so we start with an x value of 2, and we have a displacement in the x direction of -2. We start with a y value of 0 and end up at y of 1. So that's the straight line segment from 0 to 0, 1. So x is a function of t. In this case, it's 2 minus 2t. So the dx then is -2 dt. The y is a function of t. In this case, it's just t. So the dy is dt. So this is what we get from the parameterization. And we're going to take this line integral then and look at what's happening on C1. And let's see what we get. We're going to change this into an integral over t. T runs from 0 to 1. 2x is 2 times 2 minus 2t dt minus y squared, that's t squared, dx, which is -2 dt. Alright, so this was the 2x part. That was the dy part. This is the y squared, and that's the dx. So that's where all those pieces come together. So let's see what integral we get out of this. The integral from 0 to 1. The highest power of t I'm going to get is t squared. So I'm going to have 2t squared minus 4t plus 4 dt. And if I believe you go through the nonsense, you're going to get 8/3 from that integral. And so that's the work done moving the object from here to here. Okay, now what we're going to do is figure out the integral over C2. So let's sketch out C2. We're going from 0, 1 to -1, 0. But here we're going along a parabolic path. Y equals 1 minus x squared. Now, when we're given a function or a line integral like this in differential form, we already have y as a function of x. Typically what we do is this. We use this y equals 1 minus x squared to convert this integral with x's and y's into just one variable x. And I'll do that. I'll let dy then is -2x dx. So, what does this integral look like? We have 2x dy. So that's 2x times -2x dx minus y squared dx. Now, if I look at the orientation of this curve, the x value is starting at 0 and going to -1. And this is what might cause you a little bit of uncertainty, is can I get away with doing that? And the answer is yes, you can. And here's why. Here's why. I'm going to use red here. What if I just wanted to set up the integral for the opposite path? So y is still 1 minus x squared. How would I set that up? I'm going to call this curve negative c2 because that's what it is. It's c2 with opposite orientation. I'd have the integral over negative c2 of f dot dr is equal to what? The integral from negative 1 to 0 on x, and I'd have this same thing. Because the relationship between y and x hasn't changed. Okay, well, what do we know about these things? If I reverse the orientation of the curve, what happens to the work? It becomes the opposite. This would give me the opposite of the work I'm looking for. Which means the work I'm looking for is the opposite of this integral. It's the opposite of this integral. So what would happen if I put a minus sign there? Remember a property of integrals from Calc 1? If you put a minus sign here, that's the same as doing what with the limits of integration? I can switch it. All right, so that's what I'm going to do. So I'm going to erase that negative because that's not really equals to there, and just mention that. So what's the long and short of it, folks, is yes, you can get away with doing this. All right, so let's see what we're integrating then. I'm going from 0 to negative 1. What do I have? From here I'm going to get negative 4x squared dx. What am I going to have here? I'm going to be subtracting this quantity squared. 1 minus 2x squared plus x to the 4th dx. So what do I get? I'm going to have a negative x to the 4th plus 2x squared minus 4x squared. So minus 2x squared minus 1 dx. And so I find the antiderivative. It's negative 1/5 x to the 5th minus 2/3 x cubed minus x. I'm going from x equals 0 to x equals negative 1. Don't forget that's a negative 1 because when you plug that in, we're going to get a bunch of positives here. So we get a 5th plus 2/3 plus 1, and then of course a bunch of zeros. And so don't forget that's a negative 1. And you get a common denominator of 15. You get 3/15 plus 10/15 plus 5/15. That gives you 28/15. So what's our final answer? The integral over c of this line integral, of this work integral. I'm just going to add what I had before. So I had 8/3 before, 28/15 now. That's going to give me 68/15. And that's the grand final answer. So that'll do it for checkpoint quiz 20.